We must secure the network infrastructure. Everybody probably realizes this that's listening to me. But we can't do it typically with the routers and the switches alone. Even the more high-end routers and switches that we can employ in our network, even they are typically going to be doing too much for us in other areas to take on the burden of the security mechanisms. That's why this live lesson is so important. We're going to look at two classes of devices that are critical today for making sure our network is a well-protected fortress. We're going to look at firewalls, which are going to control traffic moving from one domain to another. And we're going to look at intrusion prevention systems. And we'll see how these intrusion prevention systems can complement firewalls and to ensure that our network is protected against the most common and the most devastating styles of network attacks derived today. It's time now for us to stay on a theme of network security and talk about two remarkable classes of devices that we can utilize in order to really strongly secure our network infrastructure. These two classes of devices are firewalls and intrusion prevention systems. Let's go ahead and investigate what it's very important for us to know about these two classes of security products. Firewalls, the thing I want you to keep in mind is they're just not all created equal. There are many different classifications that all fall into this concept of firewall. Notice here on screen in the first bullet point, I have a classic definition. A firewall is anything that implements access controls between domains. Think about how vague this is. You have one domain, you have another domain, and a firewall is any device that would sit between them and provide any level of access control. As you might guess, there are many different classes of firewall that can function in different ways. For instance, if you have a firewall that can look inside a packet and see some offending piece of code that's buried in there, it would be considered a more sophisticated application layer firewall. If you have a firewall that can only look at the IP address in the packet and see if that can come in your network, this would be a network layer firewall. Something else to think of when it comes to firewalls is, does your firewall take a restrictive or a permissive approach to these controls between the domains? My wife takes a very restrictive approach with me. I can't do anything, and then she allows me to do certain things. Now, I'm totally making that up, and my apologies to my wife. But you get the idea. That's a restrictive approach, as opposed to a permissive approach that a firewall may take. And that is for the firewall to allow everything to happen by default, and then define some restrictive particular things. Another interesting distinction in firewall technologies is stateful versus stateless. Stateful means that the particular firewall can literally record state information and store that so that it's really intelligent about maybe allowing someone from the inside protected network to go outside and get a resource and then to dynamically allow the return conversation back in. Stateful firewalls are more sophisticated than stateless, that aren't sophisticated enough to record information about particular conversations and dynamically allow them. Another type of firewall is one in which there's a proxying type behavior. This is pretty cool. You go to access a particular website, and this proxy firewall actually does for you. And this can be all totally transparent to you. So here's how it works. you go up and you say, in fact, let me draw this out for us. So we go to our web browser and we say, okay, we want a particular website. This proxy device says, all right, I'll go out for you and I will communicate with this web server device and that will be returned to me. I'll go ahead and do all the security checking, and then if this all checks out, I'll return it to you. Now, one of the nice things about this particular scenario is the fact that when we go to get that resource again, or someone else in our organization goes to get that resource, they can get it from the cached copy that is on that particular proxy device. So that can actually improve performance. A lot of people, when they look at this situation, they go, oh my goodness, why would you ever want to do that? It looks so inefficient. But these proxies can actually speed up. They can actually improve the efficiencies. So firewalls, really, really powerful devices. I thought I would show you one. And, you know, I've been a bit biased in these videos to Cisco systems because I'm a Cisco certified internetwork expert. But I want you to keep in mind, I've been really working hard to make sure the information that I give you applies to not just Cisco. And this discussion of firewalls is a great example of that. Now, with that said, I am going to jump on Cisco's premier firewall product right now because, you know, that's what I have all around my home network for obvious reasons. Okay, so here we're connected to a Cisco Adaptive Security Appliance. This device gets that name because this device uses an adaptive security algorithm that is stateful to allow things in and out of the firewall. And it also gets the name adaptive because it's modular and you can insert all of these various modules that will allow the firewall to very efficiently do a lot of different jobs. The adaptive security appliance can act as a VPN server. It can act as a network intrusion prevention device. It can do all this cool stuff like even antivirus work for you. Now, you're going to notice that configuring the firewall from Cisco's perspective is a lot like configuring the other devices that we saw. We can go into global configuration mode and I can go ahead and give this a name like, you know, and this name, by the way, I just broke the rules of naming. But notice that I didn't name it like firewall because we don't want to give it an obvious name like that so that someone sees it on the network and knows what it is. So I give the firewall kind of an indescript name there. And what you would typically do on one of these firewalls is you would go in and you would select the interface that connects to like your outside world and you would name it. And you would say like, this connects to the scary, unsafe outside world. And what the Cisco device does, it says, okay, you just named it outside. So we're going to set a security level of 0 by default, meaning this is very, very unsecure. And then we would give an IP address. And obviously this would typically be an outside IP. And then we go ahead and we can no-shut the interface to actually enable it. Now I go into the E1 interface, for instance. I name it inside, and the device says, oh, we're going to give you the strongest level of security on your protected inside interface, and then we would give our IP address and no-shut that. And right away, this device now, with the inside and the outside interfaces configured like this, right away, it can start doing its job of protecting the inside from the outside. Very, very cool stuff. Obviously, on a device like this, you can go in and fine-tune it. You can make exceptions to its default security policies that are built in. An example would be like pinging. By default, the Cisco firewall won't allow someone on the inside to ping an outside device and for that traffic to be returned. Doesn't allow it. If you wanted to enable that, you could go in and tune the firewall so that it could do those kinds of security permissions. Now, another class of device that I want to talk to you about is intrusion prevention systems. IPS systems. Sometimes you'll see them as IDS. D is in dog instead of P is in Paul. What's going on here? Well, a lower end device will function just as a detection system. When someone tries to do something bad to your network, it will detect that and it will send out an alert to the administrators saying, someone just tried to do something bad. And now you can go investigate what someone's trying to do. That's a lower end detection system. The more exciting technology is the higher end prevention system. It'll not only detect something bad's happening, but it will go in and it will stop. It will prevent that bad thing from happening on your network. So pretty cool. We can go ahead and we can prevent network attacks with the intrusion prevention system. How in the world does this work? Well, three common approaches that are taken are profile-based intrusion prevention systems. They know what a typical day in the life of your network is. Either you've told the device that, or you've let the device sense what a typical day is in your network, and then they'll stop something that's way out of range, like all of a sudden we're being flooded with pings. They'll prevent that. So they work on a profile of what's normal for your network. Obviously, the limitations in these machines is what's normal. I mean, look at me. Try and fit me into a normal category, right? So, profile-based have their challenges. Cisco can do profile-based. I'll give you Cisco's technologies as an example here. Cisco can do profile-based, and they do that, some of it in their systems, but what they really focus on is signature-based. The lifeblood of the intrusion prevention system in the Cisco world is signature-based, which means they know what an attack looks like. They know what the Christmas tree attack looks like. They know what the ping of death looks like. They know what a SYN attack looks like. And they put these signatures inside the machine that will look out for them. And if they happen, they'll stop the traffic, prevent the traffic from coming in the network. How cool. Cisco doesn't use a honeypot approach, but it's my favorite approach to talk about, and I love the name. What's a honeypot approach? It's a system, it's an intrusion prevention system that sits on the perimeter of your network and it pretends to be a wide open network device. It pretends to be a wide open Windows system. It pretends to be a wide open Linux system. It pretends to be a wide open router. It pretends to be a wide open switch. It's just sending out all this attack me type stuff and it's drawing the attackers to it like bees to the honeypot. And they get stuck in there because it's all gooey. What a great, great name for a particular technology. Now, here's the deal with intrusion prevention systems. I'm sure you're thinking to yourself right now, Anthony, where do I get one? Sign me up. This is so cool. I want one on my home network. Here's the deal with these intrusion preventions. Obviously, by their very nature, if you eliminate the honeypot, approach, obviously, these are very permissive in their nature. Otherwise, they're going to go haywire and shut down your ability to communicate. So they're very permissive typically, and they're going to require us to go in and do a whole bunch of fine-tuning. Why do we have to do so much fine-tuning? Because we're trying to avoid false positives and false negatives. And that's the artwork when it comes to these particular devices. Let me educate you on what these alarms are called in an intrusion prevention system. It's really easy, and students tend to have an awful time with these terms. Here's how easy it is, folks. See the first part of all these terms? True or false. Okay? It's true or false. Just think of it this way. True is a good thing. False is a bad thing. And then the next part, positive or negative. Positive, did an alarm trigger? Negative, did it not trigger? If you can remember that, you know every one of these. For instance, true, positive. Is it a good thing? Yes. Did an alarm fire? Yes. So an alarm fired when bad attack traffic was trying to get in your network. Cool. A false positive. Is it a good thing? No. Did an alarm fire? Yes. So an alarm fired when normal, healthy traffic tried to come in. That's a false positive. The next one, true negative. Is it a good thing? Yes. Did an alarm fire? No. So perfectly fine traffic was coming in and an alarm didn't fire. Perfect. And then finally, the false negative. Is it a good thing? No, it's not a good thing that this happened and no alarm fired. This means that bad traffic got to just come right in your network and wreak its havoc. So, these intrusion prevention systems tend to be very, very complex and have all these profiles inside them and all these signatures inside of them. And you're going to need to manage and tune all of this and see how the device itself is performing. And that's why most of these intrusion prevention systems are going to be managed in a graphical user interface. So instead of the command line interface like we tend to see on network devices, almost all the intrusion prevention systems that I've ever seen, they'll have a nice graphical user interface for their implementation and their imperative monitoring and ongoing maintenance. Well, folks, I hope you've had as much fun, or a fraction of the fun that I've had, in this look at firewalls and intrusion prevention systems.